Right. Now here they say to us, a farmer constructs a rectangular enclosure using 100 meters of fencing. He uses one existing boundary wall as one side of the rectangular enclosure. Calculate the dimensions of the rectangle to obtain the maximum enclosed area. Well, this is what they say. Now, this problem is one of the applications of the quadratic equations. But when you get to grade 12, you will call it an optimization type of a problem. Optimization. Okay, so what are you going to say here? Well, let's underline or rather highlight this or analyze this. That's what I wanted to say. We know the shape of the enclosure. It is a rectangular enclosure. We are also given the amount of fencing. And they also tell us that the farmer uses one existing wall as one of the sides of the rectangle. That is important. And now they say, please calculate the dimensions of the rectangle so as to obtain the maximum enclosed area. And now you understand when they say maximum, they're looking for the y coordinate of the turning point. That's just it. Okay, fine. So how do we approach this? A sketch would be nice. Let's sketch the diagram here and say, well, this is the rectangle that we will be having. But listen to what they said. They said one of the sides there is not really going to be fenced because the farmer is already using a wall for one of those sides. It can be any of the four sides. It doesn't really matter. Which one do you choose? But I'm just going to do something like this to show that one of the sides has been, well, I don't know has been what, but yeah, you get what I'm trying to say. Let's say something like this. Maybe let's say the farmer is using a wall, so we don't need fencing along that side. Well, that's fine. I like to let the length to be x and to let the breadth of this rectangle to be y. Now, this is the most important thing. Whether this side is being fenced or not, point is the area is not affected. What is only affected will be the perimeter. The perimeter, which is the total distance around the shape, would have been 2x plus 2y. But since this side is not there, then the perimeter will be x plus 2y. That's what I'm saying to you. Okay. Oh, I just realized something here. I'll be having 2y plus x, which is still completely fine. You can work with that. But I don't like having to express x in terms of y. So I'm just going to reverse this around and say x here and then y there. I don't want to end up having x equals negative 2y plus something. I don't want to work with y. I want to work with x. What am I saying? This amount of fencing, it's what the farmer will be using in order to enclose this rectangular field or whatever. So it becomes the perimeter. Perimeter is the total distance around the shape. But we know that the amount of fencing is 100. And so when we now make y to become the subject of the formula, it will be negative 2x plus 100. Why do we need to make y the subject of the formula? Well, that's because we know that the area has to be in terms of x, or at least in terms of one variable only. You can deal with it in terms of y or in terms of x. You decide. Okay. But how do we define the area of a rectangle? Well, that's easy. The area of a rectangle is defined as length multiplied by the breadth, where the length is y and the breadth is x. Then I'm going to remember what is y. Every time I see y, I see negative 2x plus 100. So, well, I can now express my area in terms of x and say where I see y, I'm just going to put negative 2x and I add 100. And when I distribute the x, well, I'm simply going to get negative 2x squared plus 100x. That is our area function. Then what do we say from this point? Well, that should be easy. We want the maximum area, which we understand it is the y-coordinate of this function, or this parabola, if you like. There are two ways in which you can find the y-coordinate. You can complete the square, or you can use the formula that says x equals negative b divided by 2a in order to find the y-coordinate, the x-coordinate of the turning point, rather. So let's do that. Yeah, it's really easier than having to complete the square. So now we have negative. What is b? B is positive 100. And now we divide this by 2 into a. A is negative 2. Negative 100 divided by negative 4. Well, that is positive 25. And we've got to say meters there. Now that we know x, we also need to find y. By substituting this 25 into the area function in order to get the y-coordinate of the turning point, yes? So it's going to be negative 2 into 25 squared. Oh, by the way, the question didn't really say we should find this maximum area-ish. It said we should find the dimensions. In other words, the length as well as the breadth. Those are the dimensions. But that's fine. We can finish this already because sometimes they can ask you to find the maximum area itself. They can do that. So let's assume they had said that. Okay. So when you go into the original function and you plug in this, well, let's see how much it's going to give you. The maximum area will be 1,250 meter squared. But I'll have to enclose it like this because, well, we were not required to find it. Let us go and find y now that we know x. Y is equal to negative 2x plus 100, where x is 25. 2 times 25, that is 50. We have negative 50 plus 100, which would give us 50. But in the original statement, you didn't have x, and you also didn't have y. And the question didn't ask you to find x and y. It said find the dimensions. So this means now you must tell them that the length must be 50 meters and the breadth or the width must be 25 meters. Those are the dimensions that will maximize the enclosed area of the farmer. This is the expression that is given to us in this case. They say to us we have 2x squared, which is added to 8x, and this is added to 10. All right? That is the expression we are given. Now listen to what the first question is saying. The first question is saying we need to write this expression in the form a into x plus p squared, and we say plus q. Remember, this is not an equation. They didn't say it's equal to 0 or anything of the kind. So you're not supposed to say x equals negative b divided by 2a. No. When they don't give it to you as a function or as an equation, we don't want to see this formula, which means that you have no choice but to complete the square in a case like this. The first thing you can see is a is the highest common factor. And after you take out your highest common factor, you are left with x squared plus 4x plus 5. Oh, a is supposed to be 2. Sorry about that. Then what? We still have our 2 outside. We take the first 2 terms exactly as they are. Then what? Then we take half and we multiply it by the coefficient of x. We square it. If we add it, we need to subtract it as well, so that we don't change the nature of the expression. And the 5 is still there. This is what we have. Then we still have our x squared plus 4x. When you say half times 4, you get 2. And 2 squared is 4. So we have 4 minus 4. And then we say plus 5. Then now we are going to focus on the first 3 terms and factorize them. And factors of x squared, that's x and x. Factors of 4, that add up to 4, should be 2 and 2, both of which must be positive. And 5 minus 4 will give us a positive 1. Then lastly, we need to distribute the 2. So this means the expression in standard form will be 2 into x plus 2 squared. Hey, but everything is 2 here, except, of course, for the x. That was the first question. But listen to the next question. The next question says, hence, which means, oh, we are not done. Oh, no, we are done. Hence, which means use what you found above in order to tell us the value of the minimum value of this expression. What is the minimum value of 16? Maybe I should write it a little lower. What is the minimum value of 16? The 16 which is raised to the power 4. The 4 is further raised to the 2x squared plus 8x plus 10. Yes, it's 16 to the power 4 and 4 to the power that. That is what I'm saying to you. In a case like this one, you need to begin from the inside and work your way outside. Well, as an example, let's say they say you have 2 to the power 3 to the power 5. How do you deal with this? Firstly, from the inside, you begin by saying, what is 3 to the power 5? That's how you begin. And you will find that 3 to the power 5 will give you 243. Then you can worry about saying, what is 2 to the power 243? And it will give you a very big number, which will be 1.41 times 10 to the power 73. That's what I mean when I say you begin from the inside and then you can work your way out. Fine, let's go on. The question is asking us to determine the minimum value of this. But then there's something we can see here. What is that? We can see that the minimum value of this expression that is inside is actually going to be 2. Because the 2x squared plus 8x plus 10 is the original expression, which we have now written in turning point form. And we can see that the coefficient of the thing is positive. So the parabola is facing up, which means it has a minimum value, and the minimum value will be 2. So then we're just going to reduce this and say we will be having 4, and now we can say 2 instead of that entire expression, because we want to find the minimum value of that. And now we can come and say, well, what is 4 squared? Well, 4 squared will be 16. This will be the minimum value. You can still write it further and say 16 to the power 16. Well, to 2 decimal places, it will be 1.84 times 10 to the power 19. Well, that is what we say.